This lesson will focus on classifying triangles both by angle and by side length. So this is probably a review lesson to you, so we're going to go through this kind of quickly. When you're classifying triangles by sides, you look to see how many sides are congruent or equal to each other. A scalene triangle is a triangle that has no congruent sides. So if you look, these markings kind of indicate this has a 1, a 3, a 2. They all have a different number of markings. That means each of those 3 sides is a different measurement. Now 2 of these look kind of close, but you can tell because of the markings on them, they're not the same. So if there's no congruent sides, it's called scalene. An isosceles triangle, that's the triangle with at least 2 congruent sides. Often we'll say exactly 2 congruent sides, but technically if there's at least 2 congruent sides, and you can notice these both have 2 markings on them, so they are congruent or equal, that's an isosceles triangle. Equilateral is a triangle with 3 congruent sides. All 3 sides are exactly the same length. Okay. So we also classify triangles by angles. And when we classify by angles, we just look, just for our angle types, acute, obtuse, right, like we studied before. An acute triangle has 3 acute angles. Every single one of these angles is less than 90 degrees. An obtuse triangle has exactly 1 obtuse angle, so you can kind of see this one up in the top is greater than 90 degrees. And then a right triangle has exactly 1 right angle. In the bottom left here, that's a right angle, so this is called a right triangle. Don't just assume things from the picture unless we ask you to do that. Usually you want to look for the markings and make sure. So let's do some example problems. I want you to classify the following triangles by both angles and by side lengths. So let's be kind of systematic here. Now this actually marks, in this first picture, it shows you that all 3 angles are the same, which is kind of impressive. And to be the same, those are all going to be acute. So by angles, we're going to call this an acute triangle. By side length, you're going to notice all 3 of these have 1 marking, so they're exactly the same. So we call this an acute equilateral triangle. Okay, B might look a little bit trickier. In B, you can notice, if we just classify it by the angles, first of all, notice there's a 44-degree angle, a 44-degree angle, and then here we've got a 92-degree angle. So since there's 1 obtuse angle, that 92-degree angle, we're going to call this an obtuse triangle. Now we have to check the side lengths. There's no markings here, so you kind of have to know something special. If there are the same angles, like here's a 44 and a 44, that means the sides across from those angles actually match. So these have 2 sides that are the same across from those 44-degree angles. And this other one across from the 92, this is not the same. You could mark it with 2 or whatever. So this is an obtuse isosceles triangle. And then the third one, when we look at this, it's going to have my angles of 56, a 34, and then a 90. Since it has exactly 1 right angle, we call it a right triangle. Again, we can kind of use that trick. There's no matching angles. They're all different. That's going to mean the sides are all different measurements. So this is going to be a right scalene triangle. Okay. Let's look at one last fact, and it will help us. The angles of a triangle always have a sum of 180 degrees. That means the 3 triangles, they always add up to 180 degrees. It's a fact that you need to know. So we're going to try to find the missing angle, and then once we know the missing angle, we're going to classify it by angles and side lengths. So I want 45 plus 90 plus this unknown angle have to add up to 180 degrees. So you'll notice 135 plus something is 180 degrees. If you just subtract 180 minus 135, you're going to get that the missing angle is 45 degrees. So notice, we have 2 45-degree angles here, 45, 45, and then we have a 90-degree angle. So when you're classifying it by angles, well, it has exactly one right angle, so it's going to be a right triangle. When you're classifying it by sides, even though we don't see a picture, we know that the sides opposite these 45-degree angles are going to match. So we're going to call it a right isosceles triangle. Okay, and here comes the last one. So 60 degrees, 20 degrees, and an unknown. So again, these three have to add up to 180. 60 plus 20 is already 80. And I need to get this to equal 180. So 80 plus, I think we know this is 100, has to equal 180. So notice my three angles, 60, 20, and 100. One of them is obtuse, so we're calling this an obtuse triangle. If you notice, all three angles are different, which means all the sides opposite them are different. So this is an obtuse scalene triangle.